Hey and welcome back. In this video I want to talk about the anatomy of an ML project. So you've seen from a high level view what a machine learning model is, but I really want to show you how this fits into machine learning with the different steps. So here you can see first of all a nice diagram of what a machine learning project kind of consists of. So here you have collecting the data. If you don't have any data, then you don't have a machine learning project. The next part is to explore the data. So you might want to visualize it, and you really want to decide for which parts of the data you want to carry on with. Essentially the part of the data that you think is the most interesting for your problem. Then you want to do some cleaning and pre-processing. I'll talk more about all of these steps, but just as an overview, cleaning the data is to get it more uniform and ready for a machine learning project, and pre-processing is a bit broader term that I'll explain later. Then we have to train our machine learning model on the data, essentially making the machine learning model learn the structures of the data and how the features relate to the target. Then we need to test the model. It's great that you have a model, but this is not like black and white, like have or have not a model. Your model might be a certain level of good. We need to understand how good your model is actually performing on new novel data. And finally, in a machine learning project, there is deployment. So now you have your model in a Jupyter Notebook perhaps, but this is not good enough. You need to make the model available for other people through various means so that they can use your model to do awesome stuff. So what I want to do is to go into a bit more detail into all of these different parts. So first of all, it's collecting the data. And I just want to say up front that this will not really be a part of this course. We will use predefined datasets when we're working. Some people call this toy datasets. I think that's a bit mean. They're more like datasets that are best used for training yourself to become good at this subject. But in the real world with real life machine learning applications, you have to actually collect the data, and this can take up a significant part of the time. So you should not underestimate this step. In any case, where do you really get new data? Lots of different answers to this. You can make surveys that you ask people to take and get data in that way. You can do web scraping to get data from the web through, for instance, Beautiful Soup or Scrapy or other Python tools. You can use log data for different systems that log out, say, performance data and so on. This is great sources of data. You can get sensor data. Say you have a temperature sensor or a pressure sensor or something like this. Sensors like this typically generate loads of data, and this is a great way to get data. And of course, you have government statistics. And just want to say what you hope the data is that you hope that it's accurate. Accuracy meaning that the data is not wrongly reported in one way. You hope that the data is complete, so there is either no or at least not too much missing data. But of course, you also hope that it's informative or relevant. So the data contains features which are relevant for predicting the task that you want. Say you want to predict the height of a typical adult. If what you gather is eye color information, then no matter how accurate it is, or no matter how complete it is, it's still probably rather useless. If someone tells you that this person has a blue eye color, it doesn't really help you that much. So make sure that the data that you gather is actually relevant for the task at hand. The second step is to explore the data, and the goal here is to get a better understanding of the data as a whole. There are many ways to explore the data. Some ways in practice is to ask how the data was collected. You can understand what different features and targets represent. This is completely essential for continuing. If you're working with features that you don't really understand what does, then you should be highly skeptical of actually using them, because then you might get surprising or unintuitive results. You should speak to domain experts about the relevance of the features. So when selecting which features to keep and push forward with, you should definitely speak to people who knows their stuff about the data at hand. A good idea is also to plot the data to gauge some relationship between the features and the target. Finally, you can also find correlations between features and target as another way to kind of find out this relationship of which features affect the targets. Remember, it's the targets that we want to predict. This is what we want to understand. So understanding which of the features is very highly correlated or very highly related to the targets is a great start. We'll learn more about this later in this module, specifically about plotting the data and gauging relationships. Step 3 is cleaning the data and pre-processing it. So just to make it clear, cleaning is to make the data uniform and in the correct format. So often when you collect data, it's in a slightly wrong format. You need to make some changes. Also, pre-processing is a bit broader term. This is everything you do after collecting the data and before training the model, I would say. So this includes cleaning the data, but it can also mean making new features from the one you already have. We'll talk more about pre-processing later in the course. Just to give you an example, in a survey, you ask people from France and from the US to report their height. This is all well and good, but then of course after you give the survey, you remember that people in the US are weird because you use the imperial system. France, they use the metric system, which is of course the only right way, while people in the US, they use the imperial system. It's not their fault, but it is a very outdated relic of the past. So now you need to make some conversions between them. You need to either make everything over to the imperial system, which would be insane, or you could do everything over to the metric system, which would be completely reasonable. So here you need to do some cleaning to make the data uniform, so being written in the same system. You also need to fill in or essentially drop some of the missing data, and you might need to scale the different features in the data so that they are of similar size. We'll do this a bit in the course, but of course the main focus of this course is in step 4 and 5, which is training machine learning models and testing them. After we've cleaned the data, we need to train the model. But what does really training mean? So, a machine learning model uses all the available data to learn essentially the connections between the features, the things we've measured, and the targets, the thing we want to find out. Each machine learning model will learn the connections in the data in different ways. This might be a bit hard to wrap your head around now because you haven't seen any models yet, but in the not so distant future, Stina will tell you about linear regression, and you have one model for doing supervised regression problems, and you'll learn many more during the course. The important thing is that each model learns these connections in different ways. And requesting the model to learn the connections between the data, this is what's called training the model. We will learn more about training in the next module and we'll work tons with this during the course. Secondly, we have testing the model. So you've built this amazing machine learning model, or at least so you think. That's great, but how do you really know that it's good? So we need a way to test the model. What is testing? So we test a machine learning model by seeing how it performs on new data. So after the model has learned essentially the connections between the data, we need to see how well it performs on completely new data that it has never seen before. In the case of the handwritten number example, for instance, I'll just write a new number on paper, show it to the algorithm and ask it which number is this and see how well it performs. There are several different criteria, what's technically called metrics, that we can investigate when testing a model. This we'll get back to a bit later in the course. And evaluating the model on sufficiently many new data values with such a chosen metric, this is referred to as testing the model. So this is essentially going to the model and say, hey, how good are you really at this task that we've built you for doing? If it's amazing, then fantastic. If it's really bad, then you probably need to go back and change some things about your model or about your data. Finally, step 6 is deployment. Deployment, as step 1, is really, really important, but it's not part of this course. We have to kind of shrink in the focus of the course a bit to not try to do everything in the world, but that means that we won't really talk about deployment at all in this course, but I just want to give you some heads up that if you have finished your machine learning model, this is your time to shine and show the world, or maybe your data science team, what you have produced. So what do you do with your model once it is finished? Well, you can embed your model into a web page or a widget so people can use it. You might serve your model as an API, if you know what that is, so that others can use it with ease. So this is essentially making your model more available to a broader range of people. You might want to automate the process of running your model in the background. You might want to draw conclusions about the relations in your data by using the model. So this essentially means that now you have our model, can we essentially use the model to understand our data better? And finally, you might want to track your model and make sure that it still performs well when the data changes. A very common problem is that you make a machine learning model that works great, and then after a while it essentially degenerates, or what people call drifts, into performing worse and worse over time because the data slightly changes. So in real life scenarios, you need to track your model and make sure that it doesn't have this data drift problem. Again, we won't do this in this course, but I just wanted to give you a holistic picture of how machine learning projects really work. I hope this gave you a broad overview of the topic. In the next video, we'll start looking at Scikit-Learn, at importing some machine learning models, and see just at their help pages to understand the basics of how they work.